let's continue section 8.5. So the second part, we are going to learn the Cramer Rule. Cramer Rule is a very convenient way to use determinate to solve a system of n equations and linear equations in n node. Let's split that into the cases of 2 by 2 and 3 by 3, since we learned how to find the determinants of the 2 by 2 and 3 by 3. First one is for two equations. In two unknown. So you're given system equations of a1x plus b1y equals d1, a2x plus b2y equals d2. Then your x and y can be solved that x is equal to, so think about the x column in here. So the column before that is D, after that's B. So it's the determinant of the matrix D1, D2, B1, B2 over the determinant of the coefficient A1, A2, B1, B2. That's how we can find x. And y, think about, take away the y column. Okay, so in here the matrix have A1, A2, D1, D2. And over the same coefficients matrix determinant. That's 2 by 2. And for 3 by 3, so you have 3 equations in 3 unknowns. We have a system of 3 linear equations, a1 x plus b1 y plus c1 z equals d1, a2 x plus b2 y plus c2 z equals d2, a3 x plus b3 y plus c3 z equals d3. Then the unknowns with the solutions, that should be the order triples. The x, y, z can be found. By showing the determinant. So for x, similarly, now you have 3 equations, so you have 3 rows. You have d1, d2, d3, b1, b2, b3, c1, c2, c3. And the coefficient one is a1, b1, c1, a2, b2, c2, a3, b3, c3. That's the x. Similarly, y can be found showing, okay, take a y column away. Then we have A1, A2, A3, those are coefficient of x. And then we will have the use the constant to replace the y, d1, d2, d3, and c1, c2, c3. The coefficient is a1, b1, b2, b3, c1, c2, c3. That's y. And z also can be found. Take away z column, replaced by the constant column. And over the coefficients, determine. Right. For the n equation rule is very similar. You just look at the n equals 2 and n equals 3 cases, you can find the patterns. Let's take a look at some example for this Cramer rules, how to use that to find the system of equation solutions. Let's start it with 2 by 2 cases, okay, and then we go to 3 by 3. The 2 by 2 cases, you can see that, let's take a look at this problem. 5x minus 4y equals 2. 6x minus 5y equals 1. Of course, you can use substitution elimination method or the Gauss-Jordan method, or we can use the Cramer rule to solve for these system equations. From the above, we know that, let me write it in a shortcut. Again, let's recall the rule we had before. If we have a1 x b1 y equals d1, a2x plus b2 y equals d2, we find the x is equal to dx over d, the determinant of x, which is replace x by the d, d1, d2, b1, b2, and the d is a1, a2, b1, b2. Right? So y will be similar, is dy over d. So that is a1, a2, d1, d2 over a1, a2, b1, b2. Let's take a look at our problem. So my x, so a1 is 5, a2 is 6, b1 is -4, b2 is -5, etc. So x can be found by looking for dx over d, right? So we just need to find what dx and d are. Dx is equals to replace x coefficient by the constant to 1 and -4, -5. So diagonal multiply, subtract diagonal multiply, so that will be -10 plus 4, -6. That's dx. How about d? D is the coefficient 5, 6, -4, -5. So that is 5 times -5 minus -4 times 6, -25 plus 24 equals -1. So x is 6. How about y? dy over d. We know the d is already found as -1. dy, replace the y coefficient by the constant, 5, 6, and the constant is 2, 1. So that equals to 5 times 1 minus 2 times 6. 5 minus 12, -7. So the y is 7. And this is our proposed solutions, 6, 7. Let's check. By substituting them into back into the original equations, 5x minus 4y, that is 30 minus 28 equals 2. That's correct. And let's take a look at the second one. 6 times 6 minus 5 times y, that's 36 minus 35 equals 1. That's correct. Therefore, 6, 7 is the solution. Right. This is 2 by 2. Let's see the 3 by 3. Let's take a look at the 3 by 3 equations also for that. X plus 2y equals 0. Negative x plus y plus z equals 1. X plus 2y plus 3z equals 0. Let's take a look at the denominator determinant. All the coefficient 1, 2, 0. This 0 is not the 0, it is 0, the coefficients of z. Negative 1, 1, 1, 1, 2, 3. Divide this determinant, as they call this. First, we use this one and cross out those, okay? So that will give us 1 times the determinant of 1, 1, 2, 3. Okay, the second one, I'm going to cross out this row and this column, minus negative 1, 2, 0, 2, 3. And the third one is cross out this one and that. So plus 1 times 2, 0, 1, 1. Simplify this. That will give us 1 times 3, that's 3, minus 2, plus 2 times 3, that is 6, minus 0, plus 2 times 1 is 2, minus 0. Right? So this is cancel out. That will give us 9 is a determinant. From the Cramer rules, and we need to find dx, dy, and dz. Dx is the determinant of replace the x coefficient by the constant 0, 1, 0, 2, 1, 2, 0, 1, 3. Okay, going through the similar process, you get that is equals to, okay, similar, so 0 times the determinant 1, 1, 2, 3 minus 1 times the determinant of 2, 0, 2, 3 plus 0 times the determinant of 2, 0, 1, 1. So this is 0 out. That one will give us negative 1 times 6 minus 0. That is negative 6. So the x can be found by using dx over d. That's negative 6 over 9, negative 2 thirds. Similarly, we are going to find dy to find y and dz to find z. In dy, replace the y coefficient by the constant, so 0, 1, 0, 0, 1, 3. That will be equals to 1 times 1, 1, 0, 3 minus negative 1 times 0, 0, 0, 3 plus 1 times 0, 0, 0, 3. Okay, to simplify this, that is 3 minus 0, so it's 3 plus 0 minus 0 is 0 plus 1 times 0 times minus 0, 0, so that dy is equals 3. Then y will be dy over d, which is 3 over 9, 1/3. And z, well, we need to find dz first. Okay, dz, replace the z's coefficients by the constant. That will be 0, 1, 0. So in this case, if you do similar step, you find out z in these is 0, dz. So z will be dz over d, that's 0, over 9, that's 0. And the proposed solution will be x, y, z equals to negative 2/3, 1/3, and 0. You can check your solution by plugging into the equation. You find out they're all correct. Right? So those are using the Cramer rule to solve for the system equation of 2 or 3 variables. So what if the method fails? What I meant is, remember, no matter it's 2 by 2, 3 by 2, you need to divide by d. So the Cramer rule fails if the determinant of the coefficient array is 0. Remember this, x equals dx over d, y equals dy over d, z equals dz over d. If this d equals 0, then Cramer rule is valid. So in this case, you can conclude either the system is inconsistent, which means there's no solution, or it has infinitely many solutions. So in either way, when the Cramer rule is failed in this case, then you need to use other method to find to conclude. So which means Cramer rules only apply when it's exactly one solution. If again, if it's no solution or it has infinitely many solutions, this method is not going to apply. All right, let's take a look at another example. Let's solve for this system of equations. Negative 3z equals 5, 3x minus 2y plus 4z equals 7, 3x plus 2y minus z equals 3. So to solve for this, if I use the Cramer rule, then I need to find dx, dy, dz, and d. Let's take a look what the d is. D is the coefficient. 3, 3, 3, 4, negative 2, 2, negative 3, 4, negative 1. Similarly, then we are going to take the 3, take up the first row, first column. That will give us negative 2, 4, 2, negative 1. Subtract the second one, 3 times the determinant of 4, negative 3, 2, negative 1. Plus 3, take out the last row, 4, negative 3, negative 2, 4. Okay, so this one is equal to 3 times negative 2 times negative 1 minus 4 times positive 2 minus 3 times 4 times negative 1 minus negative 3 times 2 plus 3 times 4 times 4 minus negative 3 times negative 2. And after simplify, this is equal to 6. So the determinant of coefficient is equal to 6. dx is replace the x coefficient by the constant 5, 7, 3, 4, negative 2, 2, negative 3, 4, negative 1. Okay. Similarly, this is equal to 5 times negative 2, 4, 2, negative 1, minus 7 times 4, negative 3, 2, negative 1, plus 3 times 4, negative 3, negative 2, 4. And if we simplify this, is 5 times negative 2 times negative 1 minus 4 times 2, that will give us negative 6, minus 7 times 4 times negative 1 minus negative 3 times 2, that will give us 2, plus 3 times 4 times 4, 16, minus 6, that's 10. Combine them is negative 14. Alright, so x will be equal to dx d negative 14 over 6. Simplify that, 7/3. Let's take a look of y. Then we enroll dy. Replace the y coefficient by the constant vector of 5, 7, 3 and negative 3, 4, negative 1. Similarly, we have 3 and 7, 4, 3, negative 1, minus 3 times 5, negative 3, 3, negative 1, plus 3 times 5, negative 3, 7, 4. 3 times 7 times negative 1 minus 12, that's negative 19, minus 3 times negative 5 minus negative plus 9. Okay. Negative 5 plus 9 is 4. Okay, plus 3 times 28, or 20 minus 21, that will be 41, negative 41? No, positive 41. So if we simplify this one, that will give us 54. So y is equal to dy over d 54 over 6, 9. That's y. Alright. Come to the last variable with z. So we need to find dz. Replace the z coefficients by the constant. So it will be 4, negative 2, positive 2, 5, 7, 3 right here. Similarly, 3, take off this one, so it will be 3 times negative 2, 7, 2, 3, minus 3 times, take off this row, this column, 4, 5, 2, 3, plus 3 times 4, 5, negative 2, 7. Similarly, if you do the multiplication, you got this is equal to 48. So z will be dz over d, which is 48 over 6. That's 8. Therefore, your solution is order triple equals to -7/3, that's your x, y is 9, and z is 8. And you can check your solution by plugging this x, y, z back to your original equation. Alright, that will conclude our section 8.5, and I see you next time.